You know the feeling. You've got the perfect spot for a TV, right? Maybe out on the patio or just across a really big room.
But you're completely tethered by that HDMI cable.
Right. It's just physics is a harsh mistress here. Copper cables just give up after, what, 50 feet or so.
Yeah, you start getting those signal dropouts or, sparkles on the screen. Or just a black screen.
Which is the worst.
Because the voltage just drops way too low to carry that really dense HD data.
Exactly. So today we're doing a deep dive into a workaround for that. We're looking at the Zenty ZT-122.
Something that essentially ignores those physical HDMI limits.
Right. We've pulled the spec sheets and architecture diagrams from each TV supply to really understand how this thing works.
And our mission today is really about convergence. We're looking at how AV is stopping being just audio-visual and is actually becoming IT.
Because this device claims to push a signal 400 feet.
Which is 120 meters.
Yeah, that's physically impossible for a standard HDMI cord without some massive degradation. Like, that's a football field plus the end zones.
It is. So looking at the specs, it's obviously not sending a standard video signal.
Right. It says it utilizes TCP/IP, which is interesting.
Yeah, this is an extender in name, but really, it's a converter. It takes your HDMI feed, packetizes it into standard TCP/IP data, and just transmits it over Cat5e or Cat6, even Cat7 Ethernet cables.
Which completely explains the distance.
Yeah.
Because Ethernet is actually designed for long-haul data stability in a way that HDMI just isn't.
Precisely, although there is a caveat in the HDTV supply documentation.
All right. They strongly recommend using solid copper Ethernet cables.
Right.
As opposed to the cheaper stranded kind you usually see for patch cables.
Yeah, stranded cables are flexible and great for short connections, but solid copper has a much lower attenuation rate.
So you get less signal loss.
Exactly. When you are pushing max bandwidth over 400 feet, you really need that physical conductivity to be rock solid to prevent packet loss.
It makes sense. Now, the most interesting part of the spec sheet for me was the name. It's called one-to-many.
That's the real magic of it.
Since we've established this is IP data now, does that imply we aren't just limited to a single wire running from point A to point B?
You hit the nail on the head. Because it's utilizing network protocols, you can put a standard network switch right in the middle.
Okay.
Plug the transmitter into the switch, and then just run lines to multiple receivers.
So you've effectively turned a standard cable box or a Blu-ray player into a whole broadcast station.
Exactly. This is exactly why you see these setups in sports bars.
Oh, yeah.
You have one game feed going to 20 TVs. And it's all managed through a simple network switch rather than one of those expensive, specialized AV matrix setups. It scales incredibly well.
But usually when you introduce compression to fit video onto a network, you definitely pay for it in picture quality.
Right, you expect artifacts.
Yeah, and the specs mention 1080p at 60 hertz. How does it handle that bandwidth without getting blocky?
So it utilizes Motion JPEG 2000 compression.
Why that specific standard, though, over something more common like HST64?
It's all about a very specific balance of speed and quality. MJPEG 2000 compresses each frame individually.
So intra-frame compression.
Yes. It is highly efficient for maintaining image integrity, which means no blocky artifacts during fast motion.
Like sports.
Right. And it completely avoids the massive latency you get from heavier compression methods. To the naked eye, that 1080p signal at the receiver looks identical to the source.
Okay, so the picture gets there fully intact.
It does.
But if my cable box is 400 feet away in some server rack, how do I actually change the channel?
You don't want to walk to the server room?
No, that would defeat the whole purpose of the remote.
Well, the kit includes IR pass-through.
Which is basically a return channel.
Essentially, yeah.
Right.
The Ethernet cable is bidirectional. While the video data flows downstream to your TV, you just point your remote at the receiver.
And it sends it back.
Right. It sends those infrared command pulses upstream, back through the network to the transmitter, then that emits them right at the cable box.
That is the part that makes it truly usable for a home setup. It preserves that couch experience.
It's completely seamless. You, as the user, don't need to know the video is traveling over a network. You just press the button and the channel changes.
It's impressive tech, especially considering HDTV supply has been in this niche for 25 years.
Yeah.
They definitely tend to curate stuff that actually works out in the field.
It solves the distance, the scalability, and the control issues all in one single protocol shift.
It really changes how you look at a building.
It really does.
Think about it. If video is just data packets now, kind of like an email, Are we approaching a point where the physical location of our media players becomes completely irrelevant to where we actually watch?
It's entirely possible.
Something for you to chew on the next time you pick up the remote. Thanks for joining us for this deep dive.